Welcome to our presentation on system reliability and block diagram analysis in DfRSoft. I'm Dr. Alec Feinberg, founder of DfRSoft and author of the book Designed for Reliability. So we're going to talk about the basic things that people do in system reliability block diagram analysis, as well as some other things for system reliability. Here's some of the basic systems that we talk about. System A is items in series. System B and C are, B and D are items in parallel. Here's 3 items in parallel and 2 items in parallel. And System C is a trunk of what we call K out of N items required to work. So let's start off with the serial system. First thing we're going to do is take a look at DfRSoft, and then we'll come back to this and see where this is done in DfRSoft. When you open up DfRSoft, you'll be on our welcome page, and you have your menu items up here. We're going to hyperlink to our main reliability tool area. And this is our actual drop-down open-style menu index page for this entire software. And this is the section for the reliability tools. You have things like field returns, statistical distributions, reliability plotting, Weibull analysis. Here's your system reliability, availability, and sparing. Then you have your quality tools like Six Sigma, CPK, lot sampling, availability and sparing, engineering tools like thermal analysis, shock and vibration, electrical analysis. So now system reliability shown here is module number 4. All the areas are numbered in modules. It's laid out like Excel with tabs on the bottom and the number areas. You can tab over by clicking on the tab or hyperlink. Let's hyperlink over. Here is our system setup, and we're in DfRSoft. We have our items in parallel, N of K area here, our block diagram system area down here. So the first thing you're going to want to do is tell DfRSoft whether you're working in failure rate units or MTBF units. So I've selected MTBF units. Most people work in those kinds of units. You can work in hours, you can work in months, as long as you're consistent, so your answer will be in the same units that you're working in. So we'll start with the items in series. That's our system roll-up block diagram, and that was shown in this area right here for items where the failure rates add. And notice that the failure rate when you're doing exponential distribution, which is what we're doing, the failure rate is 1 over the MTBF. And since we're working MTBF units, you can't just add MTBFs. You have to add failure rates, and DfRSoft makes that simple for you. And since we're working in MTBF units, DfRSoft will add that for you. So we're in our system roll-up area, and we see the systems here. We have in this area here, we have ability to put in as many as 20 subsystems and over 50 items for each subsystem, lots of area for data entry. And each subsystem you can fill in and you can label very easily in DfRSoft, and you want to make sure all the other subsystems that you're not using have zeros in it so you don't roll those up. Then let's look at what we have here. Zoom in on it a little bit. We have a transceiver section, system 1, transmitter 200,000 hours, receiver 30,000 hours, antenna 100,000 hours, another item 500,000 hours, and that rolls up into 20,000 hours. We have a subsystem, a cable system number 2, that rolled up into 92,000 hours, and another subsystem here. And the total roll-up of these 3 came to 12,500 hours. Now you can easily copy that and paste that into a presentation. What I would do is I would first put it into a blank Excel. I'm going to highlight some rows here, show you how to do that real quick, expand those out a little bit. I've expanded out all those rows, and then I'll paste the items there. I have it. Now I want to delete these two sections right here, which I'm not using, so I delete that, and that brings it over. I'm going to bring this down a little bit, and I'm going to bring this over. So that's that area right here, and I can delete these guys right here because I'm not using that, and I can paint that a little white if I wanted to. You can paint that, just make it look nice. I press F4, copies the paint color over. There we go. So I'm all ready to bring it into a blank presentation, into a PowerPoint. I just copy that and bring it to a blank presentation. I paste it in. I move that up to a corner right here. Now I usually come down and I press Shift, and then I drag this. I don't know if I did that right. I'm going to press Shift and drag that down. Everything expands out when you press the Shift key, and you can still manipulate that in PowerPoint. You can bring that over a little bit, the rows here. So you basically get the idea of how you do that. Okay, so, and you can expand it out further, and there you have it. So you get an idea of how easily it is to bring that over for a presentation. So that's our series method. The next thing we'd want to look at is items in parallel. So in that, for items in parallel, notice here's the equation for two items in parallel, working in failure rate units and converting it to MTBF. And you always want to, DfRSoft will do 2 or 3 items in parallel, but that doesn't limit you. You can do as many as you want. For example, if we had 3 items in parallel, we can always collapse 2 of the items into 1 item by using the 2 items in parallel equation in DfRSoft. And then we have just these 2 left over, 4 and 5 has been collapsed into 1, and now we have just 4 and 5 and 6 is handled by 2 items in parallel, the same equation. So you can keep on collapsing. You could have up to as many items in parallel as you want. You can keep collapsing that by using the 3 items or the 2 items in parallel area in DfRSoft. So that area is right here. Here's our page, so it's just down right here down below. And here's our 2 items in parallel area and our 3 items in parallel area. Here's 100,000 hours and 200,000 hours, and the results gives me 233. Here's 3 items in parallel of 100, 200, and 300,000, and the results is 402,000. So that's how we handle items in parallel. The next area of interest for our analysis is K out of N items required to work. So that's our this area, this subsystem right here. So this is the basic equation, a lot more complicated to use. So let's look at that in DfRSoft. It's very straightforward to apply in DfRSoft. Here is our K of N area. Now DfRSoft, I should mention, has all these pop-up instructions, so if you ever have a problem with any section, there's the pop-up instruction, as well as there's the link to the videos. Here's your video that we're talking about today, and you just click on that and it'll bring you to this video. So here's our K out of N reliability calculator, and if you put in your MTBF, all the items have the same MTBF in K out of N, K of N kinds of calculation. And you have your repair time. We have 720 hours, which is about a month to repair the repair time. So and we have 100,000 hour MTBF. we have the K of N right down here, and if you can't remember which is K and which is N, you can use the little pop-up that helps you right there. So N is there are 25 items in items that are in your K of N configuration, with 23 out of 25 required to work. So we have the results for repair and non-repair up here. The results are 12,500 hours for the no repair method, and the RADC repair method is 139,000. Notice it's much more improved because you have an opportunity to repair that and keep the system alive before there's an actual failure. The binomial method is a lot more optimistic. It gives you 963,000 hours, and your failure rate's down below. You can always add a mission time. So we can hyperlink to the mission time area for any of these. There's a mission time. It's just down below the block diagram analysis. You can add your mission time in. If your mission time is, say, 1,000 hours, and your MTBF, which we just found, was 12,514, the reliability is 92%, or 7.6% failure. So that's how you would do that. Now the next area of interest is we're going to talk about a little bit about standby redundancy for active units and non-active units in parallel. So if we have items that are active and we have replacements by switching over fairly quickly, that equation, the classic standby equation, is provided right here, and it's very straightforward to use in DfRSoft. So let's look at that. Just before I go over, I'll also point out that the definitions are provided here. So let's switch over to DfRSoft and see how you do that. I have it. Let me zoom out a little bit so you can. It's in this area right here for our K items in parallel with a total N active, and the calculator is just down below that, so you can see that. So let me zoom in a little bit now on that calculator, and you have your comments on what things are and your model information. So in this case, we have 100,000 hours for each item. We have N is the number of active units and standby units all having the same failure rate. K is the minimum number of active units required for success. So notice that N minus K is your number of standbys. Now we also have switching over probability for success. So perfect switching would be 1. So I have entered 0.9 for that. And I also have an option to put in if there's some possibility of your switch failing and your mission time. So for this particular configuration, we had N active items in standby, and K was the minimum number of active units required for success. So that was 2, and 0.9 switching, and the results is 0.96 reliability and 3,448 hour MTBF. So that's how you handle that. And I meant that the failure rate was 3,448 hours. The actual MTBF is 289,000 hours. Obviously, you're going to get a bigger number than your original MTBF. Okay, so make sure you don't misread, and make sure you read the titles like I just did. Okay, now there's other things of interest that people use in a block diagram. You might have 2 active online units with different failure rates and repair times. That can be handled by this calculator right here. You have 1 standby offline unit and K active online units required for success. You can handle that with this calculator here, as well as you have your basic switching for 1 active unit and 1 standby, which is a lot more common. So you can just do that in this calculator here. So that pretty much concludes how we do system reliability analysis in DfRSoft. Thank you for listening to our presentation.